massive amounts of particulate matter into the atmosphere. Hopefully most of you are familiar with the issue in a general sense, and hopefully to some degree maybe some of the work that I've done. But many years ago there were a statement made, and this has been the case sometimes, that there are certain statements made, and sometimes those statements are even attributed to me. And tonight we're going to pick two of those statements. The first will be about a statement to the effect that there has been a reduction in the oxygen content of the atmosphere down to a level of 16%. And so what does that mean? Well, if we look things up, we'll find that the oxygen content of the atmosphere is pretty close to 21%. This is what it's supposed to be for us to be alive. And I'll go back, now that you've at least seen this photograph, we'll come back and we'll talk about it more as we go along, because I like to be able to have some kind of contact with you there. All right, so we'll bring that picture up again a little bit later. But certain statements are just attributed sometimes to me, or made, either way. Whether they're attributed to me, certain statements are made. And there is often, in many cases, absolutely no documentation or direct evidence or reporting as to the rationale behind that statement. And you know, I guess tonight, if we have some good news, it's going to be that, you know, something's still working. And that's good. But I would have never known that without doing the work. And so this statement has bothered me. And the other one that has bothered me, if you'll notice, certain people will attribute the determination of the existence of aluminum in environmental samples by me. Well, I'm sorry, I'm not saying it's not true, but if you look at my work, you will never find me making any statement amongst 12 years of work that I have directly encountered or detected aluminum in my work. And I'm not saying it's not there. I'm just saying the statements are sometimes made, and in general statements are made, where I don't see the work to necessarily substantiate it. It doesn't mean that it's not the case. It's just that the point tonight is that we need to make sure that we do the work properly, and that we do not just circulate and repeat and bandy about talk because it's been said. With any kind of serious work, you have to put forth the effort and to describe where your work came from. So this is what happened on this oxygen thing, and I have been carrying that statement in my head for years. And the truth is, I didn't have the knowledge. I didn't have a direct method. I spent some time, but not a great deal of time. But the question was, how the heck do you go about determining the oxygen content of the atmosphere? And how difficult is that? Well, the truth is, I didn't know, but I didn't think it was particularly in my means. But I got a little bit more curious about it over the past 3 months or so, and I decided to find out whether it was possible to do. Within the relatively modest means that I or the Institute has available. And so I conducted an experiment, because on the surface, just on the surface, if somebody talks about a change in the oxygen content of this atmosphere dropping from a level of 21 to 16%, I don't know how you go about it, but this is radical, no matter what you do. And this is why I have always questioned or doubted such a statement, and I never could find any reference or source for it. 1621 is 5. That's 5 out of about 20, so you're talking about, roughly a 25% reduction in terms of the actual relative content of the oxygen. Well, if such a thing were to happen, I would think we might be having some really serious issues with just living, with just plain breathing. So I was curious enough to do this. And the neat thing is, the good thing is, that this experiment is actually relatively easy to conduct. And the basis of it, I'm going to bring up a paper. Don't worry about reading the whole paper. I'm after showing you two things. I'm after showing you the underlying reaction as to what's going on, and then I'm interested in showing you a little sketch that you will see is what motivated me with my methods. So the first is to bring up this paper. This is one of two that I used. And I'm after you seeing just that central section. Okay, don't worry about, a deep knowledge of chemistry. I'm not a chemist by trade, but I've spent some time with it. And, had some in school and this type of thing. But we're not worried about whether or not we're chemists here. But I'd like you to focus on that central statement that I hope you can see. And what it's saying is, from a chemistry side, what it's saying is that if you take iron, you take a nail or whatever it is, and you expose it to oxygen or the air, that it forms rust. That's the whole basis of this thing. And what's really neat is that this particular determination, this particular experiment, fortunately, is not difficult. And it is accessible. And it would be accessible to all of us. So the whole gist of this thing, that it took several years to get to the answer to, and that we had underlying uncertainty, at least on my side, for many years, and statements that had no basis, that were absolutely radical statements. And by the way, it was stated that this atmospheric reduction was in direct consequence, or certainly in correlation, with the aerosol operations. So now we have a chance to test it. And so that's the underlying reaction, is that if you expose some steel to oxygen, it will rust. Okay? We don't need to make it any harder than it is, and that is the basis for it. Now I want to show you this picture, and I hope you'll be able to see this picture. I have another machine here so I can see a little bit what I think you're seeing, and there's a delay. And go ahead and give me feedback once in a while to let me know that you're seeing these things, but you should be seeing a picture of a test tube in a beaker. Is that right? Yeah, good. Okay, if I just get 2 or 3 people real quickly, then I know it's there. Great, good news. All right, so this is a picture form of what I just described. And this is a particular setup that will use that reaction that we just talked about, that if you take some steel and expose it to air, that it will rust. This is a particular setup, and if you see, it's actually quite simple, that will allow us to conduct this experiment. And so I did this. Now, I did this in a little bit more detail than the picture you see, but it's the point of it that matters right now, okay? We're after the understanding of what's happening, and then we're after the results. And we're after whether or not the results are reasonable, and whether or not they coincide with what we expect, and whether or not certain statements that have been made about dramatic reductions in the oxygen content as a result of the aerosol operations have any basis in reality. Those are our goals. So what's happened there is basically you put some steel into a test tube. That's what's up top, right? And that steel wool, very fine steel, is exposed to oxygen that you have captured by inverting that test tube in the water, right? And so that steel wool is exposed to the atmosphere. And that satisfies the first part of that relationship we were talking about in terms of, what's happening. And the other part that's important about this is because it's in water, you can contain it, and you can now measure it. Okay, and it's great. What an incredibly nice, simple experiment that can tell us what is happening. And of course, at some point, we tighten up on the details here a little bit. And I'm going to go back now to us. So we tighten up on the details, right? And the details are, it means we measure carefully. We measure the volume of the water, okay? We measure the volume of the test tube, okay? And when it's full, when you first put it in there, by the way, it's full of water. So the volume of those two things are the same. We measure the steel wool and how much there is and how much volume that steel wool occupies. So we take care of some details that are important to work through this experiment so that things make sense. But the idea there is that as that iron rusts, it will consume oxygen, right? Form rust. Steel wool would become rusty inside that test tube, and it will consume the oxygen, and the oxygen will, the water level, let's say the water level in that test tube will rise. Okay? And now we'll go to my other picture, which is what I actually did. Okay, that's my picture, right? And now you see it's actually a very large test tube. One of the things I did here was that I scaled up the experiment from what it was suggested because I was after the most accuracy I could get with my equipment.